Hello everyone. Today we'll look at the code pattern digital decoupling layer for cloud modernization. What is a digital decoupling layer? Digital decoupling layer is a process where two systems can change independently without affecting each other. Now this process can be used to safely modernize a complex legacy system. Let us look at a business scenario where we can apply this particular process. This is a very common scenario for most large organizations, which is the modernization of their existing IT systems. The organizations might want to move to the latest technologies, move to a microservices based architecture, build new systems of engagement, or infuse artificial intelligence into their applications. But if you look at the existing legacy applications inside the organization, they are usually monolithic applications with very tightly coupled modules. An example of that, it could be a J2E application running on a WebSphere server and hosted on premise. Now, what is the challenge that the organization might face? The modernization of such applications must be achieved without any disruption to existing operations. So, if you look at the monolithic applications with tightly coupled modules, any modification could result in disruption of the operations, or it could also infuse defects into the existing functionality which is working fine. Now, how can we address this particular challenge? So this is where the digital decoupling layer comes into picture. So using this process, we could decouple the legacy system from the modernized part of the system so that each one could change independently without affecting each other. Next, for this code pattern, we'll look at a use case scenario and build a solution architecture using the digital decoupling layer process and implement it. For this code pattern, we take the scenario of a telecom company that provides mobile network services. The company has a legacy application with a number of functional modules. They have one for customer information management, one for mobile plans management, one for inventory management, and one for billing. The telecom company now wants to build a new system of engagement for their customers. This new system of engagement will consist of an interactive chatbot where customers can query for their plan information, billing information, data usage, get plan recommendations, and even request for a plan change from their chatbot. Looking at the solution architecture, our legacy application is a J2E application hosted on Liberty for Java. The legacy database is a DB2 database. Our new modernized system is built on Cloud Pak for data and hosted on IBM Cloud. Now, these two systems are decoupled. The legacy database is the system of record. The PostgreSQL database is the database for the modernized system, and it requires a subset of data from DB2. Now, how do we achieve this? Here, we use data stage for replicating the data needed by PostgreSQL from the DB2 database. Data stage is an ETL tool that takes care of extraction, translation, and loading of data from the source to the target destination. Here, the source is the DB2 database and the target is the PostgreSQL database. In data stage, we can set up jobs with the frequency intervals of execution. So, depending on the frequency of execution, the data from the DB2 database is replicated into the PostgreSQL database. We are using IBM data stage here to decouple the legacy application layer from the modernized application layer. Next, we will look at a demo of the code pattern solution that we have built based on the solution architecture. A GitHub repo has been provided with the code pattern that has all the sources and script files needed to set up the code pattern. The GitHub repo also has a README that gives you details on the use case scenario the architectural flow diagram, and detailed steps to set up and run this code pattern. As part of the demo, we will cover the following. First, we'll look at the legacy application. Then we'll move on to the data stage flows and see how it is configured. At the end, we'll look at the interactive chatbot that has been created using Watson Assistant. Moving on to the legacy application. The legacy application has the following functionalities. It provides you data and operations on a customer, plan, billing, and inventory. As part of the code pattern setup, we have populated some sample data into each one of these entities. Let us go into detail of each of these. Let us look at plan. You can add a plan or you can list all the plans that are available in the database. So these are the plans that are currently available in the database. Moving on to customer. You can add a customer and assign a plan to the customer, or you can search for a customer based on the mobile number or list all the customers available in the database. So let us search for a customer based on the mobile number as well. So you can see this will give you the plan assigned to that particular customer. You can go ahead and change the plan for a particular customer as well. Next, let's move to inventory. As part of inventory, we have only towers. You can add a tower or list all towers available in the database. Moving to the billing section. You can generate the bill and usage for the last 3 months given the mobile number, or you can get the last 3 months usage and the amount by giving the mobile number. So here you can see the amount and the usage for this customer for the last 3 months. Now, a part of this data is required by the modernized system, and we will use data stage flows to replicate that data into the modernized applications PostgreSQL database. So let's look at the data stage flows and see how it is configured. This is the assets page on data stage. Under data assets, you can see two database connections. One connection is for the DB2 database and the other connection is for the PostgreSQL database. Under data stage flows, there are 4 flows that are configured. The first flow is for replicating the customer data. The second flow is for replicating the customer plan data. The third flow is for replicating the plans data, and the last flow is for replicating the billing data. Let us get into one of these flows to see how it is configured. Let us take a look at the customer data replication flow. This flow replicates the data of the customer table considering customer ID as the primary key. The columns selected for replication are ID, salutation, first name, last name, and mobile. As I was saying earlier, only a subset of data that is available in the DB2 database is replicated into the PostgreSQL database. The columns selected here for replication are only a subset of the columns that are actually available in the DB2 customer table. And the write mode selected for this replication is merge, and the table action is append. For more details on the write modes and the table actions, you can refer to the data stage documentation. So once these data stage flows are configured, you can create jobs to schedule the running of these data stage flows at specified intervals. So let us take a look at the schedule page of a job to see how you can configure it. This is the schedule page for a job. This job starts on 6th July 2021 at 12, and you can repeat this job every so many minutes, hour, day, week, or a month. So the frequency of running the data stage flows can be in minutes, hour, day, week, or month. And you can exclude the days on which this job should not run. And you can specify an end date for this job as well. So this is how you configure the scheduling of jobs in the data stage. So now we have seen the configuration of data stage flows as well as the job configuration. Now we will take a look at the interactive chatbot that we have built using the Watson Assistant. So this is the chatbot preview on Watson Assistant. Now let's go ahead and enter a mobile number that's existing in the database. So once we do that, we get a welcome message with the name of the customer. Next, let us try to fetch the current plan for this particular customer. So this will send in a request to the PostgreSQL database and the current plan is fetched. So the current plan is a light plan. Next, let us get the latest bill details for this customer. So this will fetch the latest bill for this particular customer. So the bill month is May and the usage is 87 GB and the amount is $211. Next, we'll get the usage details for this customer. So this will fetch the last 3 months usage details for this particular customer. So in addition to fetching the usage details, the system has given a recommendation too based on the previous 3 months usage. It's asking the customer to update the plan to a standard plan. So let's go ahead and say yes. So this will send a request to the legacy system to update the plan. And after that, the data replication would happen and the changes would get propagated to the PostgreSQL system. Let's wait for some time before we check the plan update on the chatbot. Let us log back into our chatbot system again. Let us enter the mobile number for which we requested a plan change. Let us ask for the current plan details. This plan should have changed to standard if the data replication was successful. Yes, it has changed to standard. So data was successfully replicated between the DB2 database and the PostgreSQL database. So in this demo, we have seen how we have managed to decouple the legacy application and the modernized chatbot application using data stage. So all the database changes are first made to the legacy DB2 database and then these changes are propagated to the PostgreSQL database by data stage. This is all we had for this demo. In case you face any issues in setting up this code pattern, you could raise an issue on our GitHub repo and we will revert back as soon as possible. Thank you for watching this video.